Okay, I'm just going to have a brief look at nucleophilic addition elimination mechanism, the first example, and we're going to take an acid chloride. So we'll take an R group, so any alkyl chain. We'll attach this to a carbon R group and we'll put a chlorine on there. This is what's called an acid chloride. So it could be ethanol chloride if there were two carbons, propanol chloride, etc., etc. There's an analogous version of this, which is an acid anhydride, which we'll look at in a further example, but the mechanistic process that both of those molecules undergo is the same. And what we'll do is we will react this molecule with a nucleophile. So a nucleophile will be something with a lone pair of electrons. And in this example, we will take it as an oxygen-centered nucleophile. So we'll take methanol. So I'll just have one carbon this time. And you could have any alcohol you wanted. And also in some of the examples that we'll look at, you can also change the oxygen center for a nitrogen center. So you could actually then go from alcohols to amines, and that would then go towards more biological examples. But if we start to look at the mechanism here, what we've got the lone pair of electrons that attacks the carbon center here. This has a delta positive carbon, the delta minus is with the chlorine. But in this example, you may think that the chlorine is going to drop off, but it doesn't in this example. What happens is in a nucleophilic addition elimination mechanism, first of all, we get an addition step. If the chlorine was to come off, it'd be a substitution. So in this one, we get these two molecules coming together, and we get this, first of all, addition step. And what happens here is we then get a strange looking intermediate, which has the oxygen having picked up a negative charge, chlorine still attached, and the alcohol part is now attached down this bottom end, and the oxygen has now picked up a positive charge, which is different to what we've seen before. And the oxygen up there has a negative charge and a lone pair of electrons. So we've got this intermediate. This is a Zwitterion intermediate, so something with a negative and positive charge in the same molecule. And what then happens is we then get the elimination step of the addition elimination mechanism, and we get three arrows. The lone pair of electrons in the first example, first arrow, collapses back and will recreate the double bond. The chlorine, which we thought might come out, does come out. So this does get thrown away. And we have to then satisfy out this positive charge, and it does so by taking the pair of electrons from the hydrogen to oxygen bond. So we get these three arrows, and what that does is that then creates the new product. And what's happened is the carbonyl has been recreated. The chlorine has been kicked out. We've now got a normal non-charged bond to oxygen, which is now bonded to that CH3. So what you can see is we've obviously created here an ester bond. So we've created this ester, we've done an esterification essentially with an alcohol and an acid chloride. And what we've also done via a byproduct is kick out the H plus ion and a chloride minus ion. So that's likely to come off as HCl. So hydrochloric acid is going to come off as that product and come off as white misty fumes, as we've seen before, or as a white gas. So H plus and Cl minus coming out as HCl. Okay, and as we'll look at in future examples, changing the acid chloride to the acid anhydride will change that byproduct, because the HCl that comes off is a strong acid, and that strength of that acid being corrosive, etc., means that industrially there's certain limitations to its use. Acid anhydride gives you ethanoic acid, which will be a weaker acid, but as I say, we'll look at that in some future examples. That's a very brief overview of the addition elimination mechanism for a start.